This device is a simple electric motor. I'll explain how to construct this motor and discuss some of the science behind its operation. Electric motors convert electrical energy into mechanical energy. They use the push and pull of magnetic fields to create rotary motion. If you have viewed our video on magnetism, you will know that the opposite poles of magnets attract and the like poles repel. The poles are labeled north and south. Rotating this disc ceramic magnet moves the compass's magnetic needle. Red represents the North Pole. You may also know that a magnetic field appears when current flows in a conductor. Briefly connecting this wire to a battery deflects the compass's needle. Electricity creates a magnetic field. This effect can be used to create an electromagnet. This coil is the electromagnet in our simple motor. Connecting a AA battery, we can see the magnetic force from the coil moving the magnet in the compass. The coil is polarized. One side is north, the other is south. Let's start construction of our motor by creating the coil. Slide the permanent magnet into place. It doesn't matter which pole is up. Touching the leads to a single AA battery should cause the coil to bounce. If the coil is balanced and all electrical connections are completed, the motor should start. This is a commercially made DC motor. It is significantly more powerful and efficient than our simple motor. It accomplishes this with strong permanent magnets and large coils wound on an armature, and a method for controlling the polarity of the coil's magnetic field. Pulling the end off of the motor reveals brushes and an armature. The armature is the structure that holds the coils. Inside the motor housing, there are two large magnets, the field magnets. These powerful magnets interact with the field produced by the coils on the armature to create rotary motion. Direction of current flow through the coils is controlled by a switch called a commutator. These metal bars on the commutator are connected to the coils. Brushes deliver current to the contacts on the commutator. These brushes are made of carbon. They are connected to the external power connectors on the motor. The rotating contacts flip the direction of current flow, which also flips the polarity of the magnetic field, resulting in a powerful push-pull between the two fields. Similar technology can be found in motors powering everything from toys to locomotives.
And it consists of just 4 neodymium discs, which are very strong magnets. And then curiously here we have a ring containing 6 very small neodymium magnets. And now to make the effect, we simply have to join these pieces together. Thus, that's quite strong now. And this one here, oh, that's a strong one. To show how strong they are, we'll just bring it together and see what happens. It's going to push it away from quite a distance. Anyway, we want it to be attracting, so I'm going to put it in that mode there when it's going to come towards it, and we'll keep it away. Now the ring here, we're going to get this into repulsion mode to try and get it to push away. Oh, it's attracting. So I'll turn it over, and now it should repel. Yes, it's repelling. And now the clever part is when we put these two pieces together as an assembly, we've now got a single magnetic system in which we have one that's going to be attracted to this, and a little set of ring of 6 which are being repelled by this outside magnet. What's going to happen? When I bring this towards it, it's being attracted to the middle one, but it's being repelled by the little satellite ones on the outside. What could happen? Oh, it was attracted and it stopped. It's being repelled. There's about an 1/8 or 1/4 inch air gap there now where it can't get any closer, but not further away either. That's absolutely amazing. If I turn this one, well, nothing much there. If I turn the big one though, the ring, let's see what happens. It turns around with it, still maintaining that air gap of about 1/8 to 1/4 inch all the way around. It refuses to get any closer, and yet it won't go any further away either. It's a kind of equilibrium. It's stuck there, like an invisible arm joining the two together. It's called an inverter by the inventor, and it reminds him, I suppose, of the tractor beam in Star Trek. Invisible, but anyway, to me it's magic. It's a physics I don't understand, but it's wonderful.